Hello, my name is Jean-Louis Raisaro. I'm assistant professor at the Biomedical Data Science Center of the Lausanne University Hospital. My expertise is in biomedical informatics and data science.
Hi, my name is Bogdan Kulynych, and I'm a research scientist also at Lausanne University Hospital. And I do research, broadly speaking, on trustworthy machine learning.
Hi, I'm Bayrem Kaabachi. I'm a PhD student at Lausanne University Hospital within the Biomedical Data Science Center, and my research is around trustworthy AI in medicine and how to apply data science in medicine.
So this study is actually part of the SYNTHIA larger project, which is a public-private partnerships that aims at developing community-wide accepted solutions for standardization and development and standardization of synthetic data for healthcare. So before telling you about the object of this publication, I think it's important to discuss about what is synthetic data in the first place. So usually synthetic data refers to data that is artificially generated to mimic real-world data while preserving key statistical properties. And there are essentially two main approaches to generate this synthetic data. So the first would basically rely on manually crafted synthetic data generation process, which would be based on expert knowledge most of the times. And the second one is to use statistical or AI models that would be trained on real data and then be used to generate the synthetic data. So our paper actually focuses on this second approach. So of course, synthetic data holds great potential, right, for facilitating data sharing while mitigating privacy risks. And it paves the way to a certain number of applications that go from algorithm development to predictive modeling, et cetera, et cetera. However, there's still a lack of broad adoption of this technology because it's hard to build justifiable trust around it. So the study more specifically looked into what are the ways the community is trying to measure essentially the two main important dimensions of synthetic data, which are utility and privacy, in a systematic way by reviewing the literature from the past 5 years and try to evaluate if there's a consensus within the community for measuring those dimensions. And why is this important? Because understanding if there is an alignment will be crucial for the next step for the SYNTHIA project to establish best practices and really foster broad adoption of this technology. So this study was actually conducted by my team at the Biomedical Data Science Center at the Lausanne University Hospital, Switzerland, and by the Medical Informatics Group of the Berlin Health Institute at Charité in Berlin, Germany.
So the primary factor here is the absence of a large-scale, let's say, coordinated standardization effort across the field. So without unified initiatives bringing together stakeholders from different domains, evaluation approaches are still a bit fragmented. I would say they're inconsistent, at least that's what we found in this work. So this makes it difficult really to establish common benchmarks and to compare synthetic data quality across multiple works. This lack of standardization really creates some major problems. So first, some of the metrics lack some clear operational meaning. So it's nearly impossible to meaningfully compare synthetic data generators or select the optimal approach for specific use cases. So many people come with their shiny new synthetic data generator, but how do we actually know, especially in a university hospital, if what they propose is good enough for our use case or for another? So it makes it quite hard to understand this landscape. And another thing that some people sometimes don't think about is that it can introduce potential harm when inadequately evaluated synthetic data is deployed in a critical domains, so the medical domain in our case. So having standardized metrics would help create a level playing field for consistent evaluation, let's say. I think this is the crux of the matter when we speak about synthetic data. And we think that this privacy is overlooked for two key reasons. The main one stems from a common misconception that came with the beginning of synthetic data. So people assumed synthetic data to be inherently private because it generates fake, let's say, records when we talk about medical data. So people want to share these fake records, and since they are fake, they assume it's private. And well, this is not the case. So that is the first reason why it's overlooked. The other reason is, I'd say, it's kind of a human reason. Privacy evaluation of synthetic data is hard. It's technically challenging. It's computationally expensive, especially if you don't have like formal guarantees in the generation part. So this, let's say, logically makes the researchers go towards easier, more computationally efficient answers to tackle this problem, even though these answers may not really fit the scale of this problem.
In the paper, we provide recommendations on the state-of-the-art methods to evaluate privacy in synthetic data. And the way these state-of-the-art methods work is by simulating these kinds of attacks. Now, it's still kind of an open question of what to do when, according to these simulations, you find that the level of privacy risk is unacceptable. It's going to really depend on the method and the context, what you can do to decrease that. But there's another approach, and it is based on a set of techniques that are very well known in computer science. And these techniques are called differential privacy. And in the computer science literature, they're considered gold standard. But they're somewhat overlooked in the research and practice of sharing medical synthetic data. Differential privacy ensures provable guarantees on privacy risk by adding controlled level of noise. Because you do that, you're going to hurt utility, and possibly that's why there's a bit of a bad reputation for differential privacy. But in the recent years, we've seen a lot of developments in this field, and nowadays we have very good methods for synthetic data generation with differential privacy, so with provable privacy guarantees, and also with very mature software. And in the paper, we have pointers to all of this. There's still a lot of work to make sure that differential private methods they preserve utility well and their guarantees are interpretable. And we provide some pointers of how this can be achieved in the paper. And as part of this SYNTHIA collaborative effort, we're going to actually work on improving this. In the study, we absolutely see that there is a lack of attention and lack of evaluation of privacy properties, at least in the medical synthetic data sharing, even when the purpose of the synthetic data application is to preserve privacy of the original data. So how I see this evolving is, well, in the paper, we developed a taxonomy, which encompasses 4 different dimensions of evaluating synthetic data. So it's going to be broad and narrow utility. Broad utility is also known as fidelity. Then we also have fairness evaluation, and we have privacy evaluation. So what we found in the corpus of papers that we reviewed is that many papers only happen to evaluate synthetic data along 1 or 2 of these dimensions. And so what we recommend and what we hope to see in the future is that users of synthetic data evaluate some metrics within each of these dimensions. And that will help with the balance.
I would say that first there is an interesting imbalance in the field today. So for privacy, we have differential privacy with over a decade of rigorous research, providing multiple provable guarantees, a lot of theoretical results in there. However, we lack the equivalent formal frameworks for utility and fairness, which is, let's say, critical to address if you want to enable different synthetic data applications in medicine. So that's a point going forward. And in our paper, when it comes to recommendation, we tried not to stop at the review part. We had all these experience looking at all these papers doing synthetic data. And we also have our own experience in the university hospital working with synthetic data. And we tried coming with 4 concrete recommendations for synthetic data there. So first, we say that researchers should evaluate synthetic data comprehensively across all dimensions that we outline in the taxonomy of the paper. So we have both of the dimensions in utility, privacy, and fairness, rather than just focusing narrowly on one aspect. Second, we recommend that people who delve into this field avoid what we call conflicting metrics. So we found in this paper specifically that privacy and utility metrics that rely on similarity of synthetic records to real data, such as distance to closest record or DCR, should be used cautiously. So some papers use both of these metrics for utility and for privacy. So this makes the whole question of the privacy utility trade-off very difficult to understand and not interpretable. And third, we recommend the implementation of state-of-the-art methods for privacy evaluations instead of using simplified approaches, even though that's the easier way to do it. And finally, whenever possible, use generation mechanisms with built-in privacy guarantees like differential privacy. That way, you would be able to have some fundamental protection in the generation part of your algorithm.
The key take-home message from our study, in my perspective, is that while synthetic data holds great promise for healthcare applications, its adoption must be approached with caution. So there are currently, as we've seen, right, in the paper, there is currently no consensus on how to rigorously evaluate its utility, fairness, and privacy, which could lead to potential risks, right, especially in high-stakes scenario like clinical decision-making. So to move forward, I strongly think that the research community need to establish standardized performance metrics and best practices in order to ensure robust privacy and utility guarantees in order to build what I was mentioning in the beginning, justifiable trust. And I think SYNTHIA is very well positioned to take this role in the community. And one other important thing is that synthetic data is not the solution to all our problems, it's just part of it. An institution will nevertheless have to implement strong technical and organizational safeguards before deploying synthetic data in medical research or decision making.